This video is going to cover section 9.1 for statistics, confidence intervals involving the proportion. So if we think back, our point estimate is a statistical value that estimates the value of a parameter. So it uses a sample and applies that to say, hey, here's what we think it's going to be like in the population. Your proportion point estimate, p hat, is x over n. So if we look at this, the Gallup organization conducted a poll in which a random sample of 1,016 Americans 18 and older were asked, do you consider the amount of federal income tax you have to pay to be fair? Of the 1,016 adult Americans surveyed, 558 said yes. Obtain a point estimate. So our x is the 558, that's how many said yes. Our n is the 1,016, that's how many we asked. So that's our p hat. And you could turn it into a decimal if you want and write it that way. Either is fine. So based on the point estimate from above, can we conclude that a majority believes federal taxes are fair? So this is 54.9%. So we'd think, hey, yeah, we can. But one thing we have to remember is different samples give different numbers. So they'd have different proportions. So when we report out, we report a range instead of just a number so that we can include them. This range is called a confidence interval. How we do that is we give the point estimate and then we say plus or minus some margin of error. So I might say like plus or minus 5 or plus or minus 2% or within 3%. Those are all ways of showing a range. So the margin of error is how far above or below the point estimate we're going to go. And then our level of confidence, 1 minus alpha, is how we calculate the level of confidence. And it's just how sure you are that the real value is within that range. So in the above survey, Gallup indicated the margin of error was 0.04. They also shared that their interval had a 95% confidence interval. So if our point estimate was 0.549, we're going to add 0.04 and we're going to subtract 0.04 to get our margin of error. So if we add 0.04, we get 0.589. If we subtract 0.04, we get 0.509. So that makes our range 0.509 to 0.589. So that's our range. And 95% confident means we're 95% sure the real proportion is within this range. That's what that 95% means. So mathematically, this is how you calculate the proportion. So z sub alpha over 2 is going to be on your z table down here in the bottom. It's called the critical value. It's saying if we're 90% confident, this is our critical value. If we're 95% confident, this is our critical value. So these are just a shortcut. You can also find it in the chart. But you plug that in and then multiply it by the standard deviation of p. Now, in reality, we're probably going to use the calculator, which I'll show you, but that's there. So you use the confidence level in the z table. So the more confident you are, the wider your interval. That's why this number gets bigger. We want our interval to be wider so that we can be more sure it falls in there. So let's look at how we would use that. In the parent-teen cell phone survey conducted by Princeton Survey Search Associates, 800 randomly sampled 16 to 17-year-olds living in the U.S. were asked if they had ever texted while driving. Of the 800 teens surveyed, 272 said yes, obtaining a 95% confident interval. So first we're going to find p hat. Well, p hat is 272 over 800, which gives us 272, nope, 272 divided by 800, 0.34. And then we're 95% sure, so we're going to go back. 95% is 1.96. So now I would plug it into that equation. So the margin of error is 1.96 times the square root of p hat times 1 minus p hat over n. And if I put that in the calculator, 1.96 times square root of 0.34 times 1 minus 0.34 divided by 800, and we get 0.033. So that's our margin of error. And then we do 0.34 minus 0.033 and 0.34 plus 0.033, and that gives us 0.307, 0.373. So we are 95% sure the real population percent is between 307 or 0.307 and 0.373. So that's how you do by hand. The calculator will also do this for you. On the calculator, you are going to hit the stat button. You're going to arrow over to the tests menu, and then you're going to scroll down to A, where it says 1 prop z int. This means we're dealing with one proportion, we're dealing with a z-value, and we want an interval. So let's do that. So, well, I'll get the calculator at some point. All right, so I hit stat, arrow over to tests, and go all the way down to A, 1 prop z int. And then we enter our information in here. So our x was 272, our n was 800, and our confidence level was 95%. So we would do 0.95, and then you hit calculate. And at the top of your screen, you're going to see this parentheses where we have 0.307 to 0.373, and that's our interval, which happens to be exactly the same. So that's, you can do it by hand or by the calculator. Now, maybe we don't know the percent, we want to figure out the percent. So in order to do that, we have to use our critical value to decide how many people to ask. So suppose we want an estimate within a 3% margin of error and 95% confident. How many people should you survey? So this is the equation. N equals p hat times 1 minus p hat times the critical value divided by the margin of error squared. Same margin of error we've been talking about, same critical value we've been talking about, same p. If they don't give you a proportion ahead of time, you're going to use 0.5. So if you don't know, you're going to use 0.5 for each thing. If you do know, then we're going to use it. So let's look at that. An economist wants to know if the proportion of the United States who commute to work via carpooling is on the rise. What sample size, so this is our hint that we're doing the n equals, should be attained if the economist wants an estimate within 2 percentage points, 90% confidence. So we're going to use the 2009 estimate of 10%. So they're saying, hey, use 0.1 for p. So we're going to do n equals 0.1 times 1 minus 0.1. And then we go to our table. 90% is 1.645. I don't know why I put p here. It should be 0.1. And then our margin of error is 2%. So we're going to divide by 0.02 squared. If I type that in the calculator, 1.645, you get 608.8, and you always round up no matter what. So we're going to ask 609 people. Now let's say we didn't already have an estimate. That's when we use the 0.5. So 0.5, 1 minus 0.5. The other numbers aren't going to change. We just don't know a prior percent. So if I type that in, I'm going to get 1691.3, which means we have to ask 1,692 people. The biggest part is showing, hey, if we don't already know a percent, we have to ask way more people to get one because we have nothing to narrow it down to. So that is 9-1. Let me know if you have any questions.